Hey guys, sorry I'm late. Wait, we don't have Helia online? Oh, she is. Okay, good. Sorry.
Good morning. Yes,
Hey,
I'm
Helia.
here.
All right, Ram. Yeah, I'm glad you're here. And Paul, you guys are so um the damn spec is in Stacy's, but Helia has one question which I think is worth a bit. Let me pull that up. Um But I think the most basic thing is why don't we have, if I understand it correctly, why don't we have the chip address space partition registers that we have in the die port spec? Why don't we have a similar set in the link control spec? That's the question. And I really can't think of a good reason why we wouldn't do so.
Yes, definitely, Bob. You definitely got the essence. I was going over the diaport spec, which I believe is not 100% fleshed out. And there is a very nice and definition that captures the memory mapping. And this seems a great feature for multiple reasons. And and I was wondering where the spec is and where the status of that is. And when I reached out to Boppy, I was hoping that the answer would be there, and this is the status. But he said, well, this doesn't exist anymore. And he liked the feature. So that's where we are. Do you want me to? So if you jump to maybe section 5, that's where
These, right?
I think, yes, but if you go further up, that there is a
Oh, they're up.
table. So if you just click on section 5, yeah, the first section, yes. And yeah, these registers you see the logical address region and physical address region. So what we have in dieport, if you want me to just quickly go over what we have, and I think what would be a nice extension from there, I can start with that.
Please.
So what dieport put in place for spec is that it has a local address mapping or local address translation to remote address translation. So on the master axis side, when the transactions are initiated, all the master axis side in that chiplet would see is basically its own local address space, which we can call the logical address space, and does not know anything about the remote side, the remote chiplet address space. And this is very good for multiple reasons. It improves the dependencies of two chiplets. It improves the modularity of two chiplets. If the address space of one is going to change, if we respin one chiplet, we don't need to respin the second one as well. So that is some of the reasons that it's very good to have that address translation. And what is explained here is that the local logical address space on the master is what is visible for the local chiplet and where the transactions are initiated. And in that master side, the local address is translated to the remote physical address space. So there are two registers, as you see. Let me see if I can turn on my annotation. Okay, so this is the local address that the AXI bus on the master or on the local chiplet talks to the talk. That's the language that it talks, and then it is translated to physical address space, which is on the remote chiplet. And this is what the the size of that region is. And in Diaport, it has 8 such regions. So there are 8 translation blocks that is very parallel, if you want to think about it, to PCIe bars. That is the concept that is defined here. And this is, if you go further, this is for 32-bit addresses. And Boppy, if you go a little bit lower, it also shows how it can expand to 64-bit. Yeah, here. So these are the, if one is going to use 64-bit, so these are how the addresses are going to extend it to 64-bit. So I think this is the concept, but I think we probably should think about how to extend it. I'm coming from the AI HPC backgrounds, and I feel that so when I look at Diaport, the maximum memory that it can translate is something about 16 gigabytes, the total maximum that it can map. And I think when we are looking at AI HPC type of application, think about Grace Hopper, for example, interface, right? NV chip-to-chip link. That ideally we like it to map 1 terabyte. Of course, that will be over multiple channels. So I think what Diaport has is 16 gigabyte memory mapping. If we extend that by an order of magnitude, or more than that, that would be very strong specification.
So
I have a quick question here. So you correctly mentioned that this is very close to how PCI defines its bars. And the reason for PCI to have bars is because PCI defines a topology. But for BAO, I don't think we are defining a topology. It's a point-to-point connection. It's basically kind of looked at as a transport medium between one chiplet to another. But there is no topology requirement in place. So I'm a little curious to understand where else would this be useful from a BAO standpoint.
I agree with you, right? PCIe is defined for a very specific within two domain, and kind of specifies the memory maps of multiple endpoints to one host. That you captured it beautifully. Bobby, may I quickly share something
you can,
from?
of course.
Yeah, from ODSA.
But I've got an answer for Ram while you're pulling that up.
Please.
So Ram, my vote is, look, the BAO is a mechanism means for die disaggregation. Yeah, okay, there.
Okay.
Okay, I swear we didn't rehearse this, but it is a means for die disaggregation, and so address space allocation across your disaggregated die is not strictly a function of the die-to-die interface itself, but it is what we're trying to achieve in the ODSA, right? So that's and this seems to be a pretty decent place to bundle that feature in. That's my sort of that's why I sort of reacted very positively when Helia suggested this.
Got it. I mean, if I recall, I mean, sometime back, I mean, long time back, I think, yeah, I mean, I was all up for a common, defining a common address map. But at that time, I think the general direction was to keep this as flexible as possible. But yeah, I mean, if we are moving towards a direction where we want a common address map and define all these features in, I think, yeah, I would definitely support it as well.
And so the key question is, I think the way, at least my thinking is all in a greater understanding of the register definitions on the interface, etc. So, should this be a mandatory part or should it just be an optional add-on that you can define these address spaces as, sorry, Helia, go ahead, please.
No, yeah. Sorry, I didn't mean to talk over you. Yeah, go ahead.
No, go ahead, please. I'm more than happy to wait.
I wasn't talking. I don't know. Maybe
No. You
not,
pulled up
but
the
yeah.
slides and you had something you wanted to say, right? So
Oh,
I wanted you to
okay.
finish. Please finish your thoughts.
So this is my thought that as you very correctly said, Ron, that when we have the board on package, we have such independencies basically on the two chiplet, and they can come from two vendors, and they talk PCIe, which gives us that isolation and transparency, right? That we really do not want to see one for modular development and the other one is for securities and protecting IPs and whatnot, that we really want to put this PCIe. As Bobby and you also mentioned yourself, the way that kind of disaggregate die is, in my opinion, one of the most important feature is to keep the modular design. And you also mentioned flexibility, and my goal is to promote flexibility here by having each of the chiplet would define their own address region. And because imagine chiplet 2, for example, has one address region. If we don't have that translation, that means that basically these are all wires at the higher level, at the AXI level. And this AXI system would look at the chiplet 2 system, knowing all the detailed address map. If there are fragmented addresses here, there should be fragmented addresses here. And this means that the design of chiplet 1 will be impacted but by the decisions that we make in designing chiplet 2. If we have these buffering in between, and buffering by, I mean by modularity interface in between, that could be achieved. That's where I'm coming from, and I think this would be beneficial to the ecosystem if we have. But I'm gonna, if there's no question on this, I'm gonna close this unless you need that, Bobby. And
No, but I think I get Ram's point is this has, you're kind of moving from a controller for a link to a controller for a device in this, if you, or if you have a controller for a link, you're depending on the user to sort of make sure there's no conflicts in address space assignment, etc. On this. If I think, at least if I understand your point, that's how you're sort of saying you're going into the device space rather than just the link itself. Is that a fair way to parse what you're saying, Ram?
Somewhat, yes. Because I mean, from my perspective, yeah, I mean, what Helia suggested at the address map, I think that would all be coming under the diport controller.
Right.
And then that would talk to a bow link and a bow phi on chiplet 1. Going into chiplet 2, there will be a bow phi and a bow link. And the link will send the details to the diport controller, and diport controller would ideally do the address translation. So from that perspective, yeah, I mean, I always looked at bow as a transport medium,
Right.
and not as something that we have topology on.
So the key question is, should the address map be a property of the transaction layer, or should it be a property of the underlying transport mechanism? Because here then likely you didn't have diport as your transactions, but you had some other transaction layer, they would have to develop roughly a separate parallel address map for their controller. Pretty much any transaction layer needs an address map, right?
Correct.
And so, is there merit in, should we make it a property of that transaction layer, or it feels kind of appealing to just make it a property of an ODSA controller?
Just to get a context right, when you say ODSA controller, are you using that? I mean, is that the same as BOW link controller
Yes,
or?
in the control path spec, just
Okay.
make room for a register set. I mean, in theory, you could just sort of create a separate private extension, but easy, just deliberately specify these and say, hey, if you're going to do an address map, do it this way.
Got it. Yeah, I mean, from a spec perspective, yeah, I mean, if you want to consolidate everything and consolidate BOW into the ODSA transaction layer, then probably it definitely makes sense. But
Anyway,
I
that's
would
my take. I'm
others chime
happy
in
to.
as well.
Sorry.
I would let others chime in as well,
Yeah,
but I think,
exactly,
yeah, I mean,
exactly.
if
Okay,
the
we're gonna have the
intent
same.
is basically to consolidate things, then yes, then the transaction layer, it would be good to have a well-defined transaction layer and well-defined address space for the transaction layer, so that this becomes more reusable across different vendors.
Right. Exactly. Exactly. Paul, Boonchong, Quinn, Anshu, whatever.
Yeah, no comments. I'm just trying to follow what's going on.
Okay. Paul, Quinn. Thanks, Boonchong.
Yeah, I'm kind of in the same camp as everybody else. So I assume this is not talking specifically about the sideband stuff. This is more generic link layers.
Well, let me show where I think it would go if we did it. You see where? Whoops. Oh shoot! Is this being recorded? Damn. Okay. Idiot. All right, I gotta kill this recording. Hang on. If here in this register set, we would on top of linked registers, we would just define transaction sales pay, transaction address registers.
Right. So in my view of the world, it's not possible to initiate a transaction into the access into the transaction layer, right? Beyond the BOW5 from sideband.
But you're essentially providing an addressing service to the transaction layer from this controller. That's all you're doing. That's the plan. That's the intent. You just sort of saying, hey, specify the map here. We're not going to actually initiate any transactions from this.
So I don't know what that map would be doing then. Who would be using that map?
Any transaction layer protocol would use that map.
Yeah, and that's fine. That's not running over sideband, right?
No, it would run. It's a main data path transaction layer protocol.
Sure. Yeah. So now I'm catching up.
Okay.
Yeah, and I'm perfectly fine with that. I'm not aware too much of the link layer stuff going on in the BOW stuff.
Sure. It has nothing to do with the sideband. It is essentially defining another set of, like we have link control registers. We're also defining address space registers, for lack of a better phrase.
Correct. Yeah, that's perfectly fine. I understand that and also see the need for that.
Yeah.
I kind of agree with Ram though, right? That this is kind of like more a point-to-point thing, and
Yes.
maybe it's not necessary. Certainly, the flexibility might be nice to have, but I'm not sure it's necessary.
Correct. I mean, and the key thing we're saying is, okay, you have a bunch of bow interfaces together, decompose an SOC, and this is how the address space in the SOC is being decomposed across these bow interfaces. That's and the intent is to capture that address space decomposition within the controller.
Sure.
And so every transaction will have to have some kind of an address map. The big thing is we just standardize that and say do it this way across all possible transaction layers instead of everybody creating their own.
The challenge I see for this is if we start down this path, there's sort of a whole complete it. It's not just the address range, but then if I see a transaction that is I'm supposed to pass through, having the mapping of how to forward, there's sort of, if we start going down this, I think you kind of have to go all the way down this, and that's where I guess I struggle.
You don't think we could version it? Sort of just put the space for the registers and then figure it out in the next version? They say we know this is a gap. I'm asking.
Maybe.
I'm
Yeah,
asking.
I mean, you could always do that, but if you kind of, if we put the address range, but then you don't sort of go to that next step to have some sort of mapping table, I feel that we're kind of, it's not useful. It may not really be useful.
Well,
So that's my
you're basically
concern
saying if I define a link layer, I have to define roughly a switching mechanism as well, for switching and forwarding mechanism.
Just a map, some sort of mapping table, but that's I guess my question, if you're gonna start doing address space, then it sort of begs the thing, well, but then I really need to define a mapping table of some dimensionality. I guess that's where I struggle, is where do you stop?
But, well, isn't that a property? So if the transaction layer doesn't need any transactions between devices that aren't directly connected, that mapping table is not useful, right? The transaction layer has to support has to support transactions between any two addresses. You could just basically say at this point we only support transactions between devices that are directly connected.
I guess you could, if you limit it to that case, but yes.
We could just say, like, right now we limit it to supporting transactions between directly connected devices, and future rev we will expand this to sort of say, okay, how do we actually say this is the way you should implement a switching function?
Okay, maybe that is a sufficient, I mean,
because I don't know of any transaction layer that is actually looking at between. I mean, Helia, I don't know whether you guys have an app which needs that between transactions between devices not directly connected to one another.
At this point, it's point to point. Yeah.
Because it's not dynamic, right, Quinn? This is a static environment with a statically connected network.
oh yeah, it's static. It's not hard. If you want to say that we're only, I guess with that restriction, then maybe I withdraw my, as long as we explicit, that's the restriction that this works. And then anyone doing multi-hop is doing their own proprietary derivative.
Please extend and give to us. But I mean, the reason, at least I'm drawn to it, like what's the expression, either fly to a jam jar or a moth to a flame, is this is the first explicit codification of SOC disaggregation. This is the first time we're explicitly codifying support for SOC disaggregation into a spec. Other than the diport, of course. And it's something I've struggled to express in some tangible form, other than saying we support SOC disaggregation.
Bapi, one suggestion maybe is to keep the bow link in the bow transaction layer as separate. And when it comes to the transaction layer, then we can probably, there is one way to do this is to reference to the diport transaction layer spec and say we can probably use something similar to that. So that way, I mean, implementations that only look at point to point, they don't need to worry about implementing registers that are not needed. And it's just a suggestion, but I don't know if that answers your question or gives you some
Could
idea.
I achieve that by saying optional address space definition registers or something? Address mapping registers, or just these link state registers, the link control are mandatory, but could we just create a section saying recommended address mapping registers or something?
What I'm trying to suggest is to keep the link spec and the transaction spec separate.
Okay, then how do we? How do I? So what? Okay. But it involves writing one more. At this point, really, all we have is an address space, right? Could mechanically, it's a decent amount of work to create one more spec, and we're really talking about address mapping registers and nothing else, right? Is there no clean way to integrate them, you think? Well, okay, let me start with the top one. Do you guys feel that, do all of you feel that this is a valid service to offer, for a spec to offer, a spec, if not this spec, for a valid service for a spec to offer transaction layers that, hey, let's standardize the way addresses are mapped for SOC disaggregation? I'm asking, not commenting.
If this is a vote, I would definitely say yes. But I would also prefer to keep this out of the link spec.
But wait, this is not in this is a controller spec, right? I see, we're calling the link control path. Okay.
Clarifying question. In that diagram that you're showing,
This one.
there is a box around transaction and link layer
Yeah,
specification, which goes to the controller.
Yeah, there is. And that's it. So our energy is focused on this little, whatever, red or orangish box, red, I guess, right? And we've never really talked about this blue box.
And this document is about the vertical rectangle on the right.
It's about this dotted thingy here.
Yeah.
So Ram, this feels like this is an extension of this blue box into the controller saying this is the API into the transaction layer, control API into the transaction layer. I get your point too. Okay. No, if you guys feel roughly the same with the same degree of certainty that it shouldn't be in the spec, I will leave it out. But it feels like we're dealing with this upper blue layer, and just the address space alone doesn't merit a separate standalone spec. But I think there's tremendous value in specifying and address translation register, address mapping registers right now.
It will evolve into its own spec when we deal with the multi-die solution.
Yeah.
So maybe we could consider it the baby step to that.
Yeah.
As opposed making it its own document, knowing it actually is going to become something more complete.
But man, writing one document to say an address mapping register feels like a.
I understand that it's overkill for the first step.
Yeah, it feels awful. I mean, in the Bo sideband, what we did was we put it in the Bo spec, and then we're eventually pulling it out into its address mapping registers and all these things. And I thought we'd have a similar sort of path here. Just throw it in here and then start expanding and pulling it out. Okay, so are we agreed on the need for something that does address maps? Are we at least all in sync on that? Yes, we need that. Under the constraint that it's for directly connected devices, is there anybody who thinks that's a bad idea? I mean, is there anybody who thinks that we shouldn't be going down that path? It's a question, not a comment. You guys had helped me out. I'm gonna pick on you with names like Quinn, Ram. Is this a good? Is this a thing we should do? Ram's already spoken up and said we should do this, just maybe not in this document, as I understand the constraint. But is anybody else who thinks we shouldn't do this at all?
I think we should do this.
Okay. So the key question is, do we make this a section in this document or we make a separate document out of this? Okay, why don't I start to do it this way? Since this document has been in stasis for an eternity, why don't I add a section to this and put some because the overhead of writing a separate document is such a pain in the neck. Why don't I add a section to this? And if all of you barf, we will sever it and pull it into a separate document. Can we try that route? If it's as ugly as all of you are afraid it is, then we'll yank it. Otherwise, just creating a separate pushing a separate document through the OCP process just for the address map is a royal pain in the neck. Is that doable? So what I will do is I will create an entirely separate section that's not linked to anything else. Just call it, we will call it the link and transaction control path and expand it. And I will create a separate register set called address map registers. That's a subset here. And we should be able to just yank that whole thing if it looks truly ugly. And Helia, I'll need your help on which registers or which cut and paste from the DIPort spec we need.
Yeah, I kind of feel I'm obligated to give a hand.
Oh, my favorite kind of answer. All right. Anybody have a serious heartburn over that? Ram, I reckon. So I understand your concerns. I'll put it as a completely severable thing that we can just delete if it looks truly awful. If it looks really as bad as you think it does.
Works for me.
Okay, Quinn, can we live with that?
Yes.
Okay, Bonchong Paul.
Yeah, I'm happy with that.
All right, sold. Okay, so we'll go down that path, and hopefully I need to get this all settled by the new year. Hopefully, at least take Paul's questions into account. Did you have any other questions, Paul, from your previous time that we didn't go over?
No, not at this time.
Okay. In that case, I think that's it. Helia, anything else in your mind?
No, thank you.
Okay. Hey guys, I'm gonna have get this recording be deleted because unfortunately there's some personal information there which unfortunately I forgot to shut down. So don't look for the recording. Well, in that case, no meeting next week. I'm going to cancel it. Merry Christmas, Happy New Year, and everything. And hopefully, I have some progress. We have some progress. Helia and I have some progress to report by the time the new year rolls around. Do you guys want a meeting 1.4 or should we just meet 1.11? Am I asking again?
I'm okay either ways. I'm available on 4th and the 11th, so it doesn't matter.
Okay. Why don't I play it by ear then? If we make good progress, then I will set this up. I'll set it up. If we don't, then I'll just punt to the 11th.
Okay.
Hey, we need everybody's things signed. If you haven't signed it already, if you have, great. If you haven't, please get it signed. I don't think I have, so there's that. So. All right. On that bright note, thanks all.
Thanks, Poppy.
Thank you.
See you in the
And
new
Merry
year.
Christmas and
Wait,
Happy
wait,
New
wait, wait,
Year.
don't go away. Don't go away. Wait. There's something I forgot to tell you. Right. I knew there was. So on February 9th, after the Chiplet Summit, you saw my note yesterday in the mailing list. We're holding a a experience center demo day at Lawrence Berkeley Labs. So Ram, you guys usually, if you and the idea is to sort of do a 30-minute demo centered or show and tell centered talk for any companies that are interested. So if Ram, I'm hoping you guys will show up. And Helia, if you guys want to participate, you're welcome to as well. The idea is to share not slides, but if any company has something, a prototype, a 3D model, anything sort of touch and feel, the idea is to sort of do a show and tell for 30 minutes. And the next step after that is we're looking at leaving some stuff on permanent display at Lawrence Berkeley Labs. So if your companies have anything, this is a good place to do the demo.
And this is around die to die and chiplet.
Or anything in
Or-
chiplets. So chiplets IP, chiplets workflow tools, chiplets themselves, software analysis tools, performance analysis tools, any kind of a model, anything.
Okay, thank you.
Sure, I'll check with my internal. I mean, we do have test chip that is working. So
Oh yeah,
I
but if
can-
you guys, the answer is only yes, man. It's just a question of who's going to do it. We need you guys, so for sure.
Okay.
Hey, sorry, hey Bobby, how does one attend the chiplet summit? I don't see a sign up or a register link.
There is here, right? But it's pretty pricey.
Ouch. Okay.
It's really pricey. Hang on, I think it's like $600 or something.
Can somebody volunteer and help out, and or maybe I'll take it offline with you.
Yeah, hang on. Let me give you the link. There.
Okay.
You can attend, I think the OCP tutorial the previous day, you can attend at no charge. The Chiplet Summit itself, the next 2 days, there is a registration fee.
Okay. Sounds good. Thanks.
That's it. Thanks all. Hey, wait. Oh, shoot. Sorry. There's one more thing. I'm sorry. I'm remembering. Hey, Quinn. Actually, maybe not. So the other thing we're trying to do, right. I'll send out an email about this. On February 2nd, right? Last year, what we did was we did like a sequence of talks on business barriers to doing it to chiplets, to sort of say like what are the issues you face in sort of creating chiplets or creating products for the chiplet economy. We're thinking of revisiting and reaching out to the companies who did the talks last year and asking them if they have any updates, and also any new companies. So and the basic idea is to sort of say, look, either you're pre-silicon or you're post-silicon, or in bring up or post bring up in trying to get a design win. What are the constraints? What are 1 or 2 significant constraints you're facing that that you're willing to share with people, and maybe there's some room for us to develop common infrastructure. Those are the 2 big events. So stay, if you're subscribed to the mailing list. If you're in the business of making a chiplet, we'd like to hear from you and to sort of share whatever it is you're willing to share on the business barriers. And Quinn, I thought we could make it in person, but I'm assuming February 2nd in CMU, the rooms are booked and things like that. Is my guess.
I can check what dates.
February 2nd.
February 2nd.
Yeah.
Send me an email and I will follow up to see if I can get the room for then.
Okay. Sounds
What
like a
time
plan.
would you want? Do you know the time you'd want it?
Morning. Usually instead of our regular weekly meeting, instead of 8 a.m., so either 8 to 12. But if it's available in the afternoon, I'm thinking something for 3 to 4 hours, no more than that.
Okay. Yeah, I think we're going to be in session, so it'll be hard to take that much space for that much time. But I can at least check.
Okay. Yeah. It's a 4-hour window. I think we'll have about 25, 30, the same kind of thing, right? In person was a really good event. Everybody was sort of open about it.
Okay. Let me see what I can do.
Thank you.
Do you think it'll be the same size? We need that same amount of space, or would smaller?
I think smaller is okay, right? I mean, we only sort of 40% filled it, you think?
Yeah. Okay. Let me see what I can do.
All right. Thanks.
Okay.
Thanks all.
Thank you.
Bye.
Bye.
Thank you. Merry Christmas.
Merry Christmas.